Have you ever wanted to know how attackers are able to find control systems that are exposed to the internet? And that's what we're going to really start to dig into in this section. And so as we get into and talk about traditional search engines, so think of Google, Bing, DuckDuckGo, right? Those are probably the big ones that people use today. That's what we're going to be using in this section. So in this part of the course, this is where we shift from more of the traditional, not to use the word again, but traditional IT OSINT tactics that we use to now we're starting to focus in more in the industrial control world. And so as we get into looking at control systems, right, how they get exposed to the internet, well, how do we find them? Again, we want to find them before the attackers are able to find them and use them against us. Now, we already touched on using Google earlier on in the course. Remember, we use Google and if you want, Google Dorks to create the search to allow us to find subdomains or different hosts, those fully qualified domain names, within the netflix.com domain. So that was a form of, if you want, Google Dork, kind of, sort of. You'll see what I mean in a second. But going back to this point that, well, Google indexes anything that's a web page connected to the internet. So if you have control systems like PLCs or HMIs that have a web interface, and we'll see some examples of those, that if they're exposed to the internet, Google will find them. And then it'll make that available for you within Google. So a lot of times when we talk about OSINT and finding control systems on the internet, we always talk about Shodan, which Shodan's awesome, no doubt about it. And we're going to talk a lot about Shodan in the next section. But you don't even have to go to that link to find different control system assets on the internet because of Google. Again, as long as those assets have a web interface that's exposed to the internet. So we're going to look at some of these different advanced search operators, which allow us to create these specialized searches, or what they call Google Dorks. I think a lot of people have started to move away from the term. So maybe we'll just say advanced Google searches. But it allows us to go through using Google, right, the largest search engine in the world, to be able to find, if they're out there, control systems that have web interfaces on them and they're exposed to the internet. And the nice thing about this, just like all of the other OSINT tactics and techniques we've been using, is we're not sending any packets towards the target environment yet. We might want to visit one of those web pages, and there's nothing illegal about doing that. If you start digging a little deeper, that's where you're crossing the line from our perspective. But we're going to look at that a little bit more as we find these hosts through Google. And then, yes, Google is, of course, free to use. Even though, of course, yes, they give you ads and it's not technically free to use, and there's always that conversation. But anyways. So Google does have these advanced operators that you can use. And we used one of these earlier. Remember, we used the site advanced operator to say, only show me results in Google when I run a search that are related to a specific site like Netflix.com. So that's one that comes in to use frequently. There's a couple others that are worth mentioning, and there's more, of course. I think some of the big ones that I've had luck with over time are things like cache. So you might actually go to visit a web page and it's not available. Maybe somebody had posted sensitive information, they realized it, they found out somehow, and they took it down. But Google might still have that cached if it was indexed. And so you can click the cache option if it exists, and you can actually pull up the web page almost as if it was still in existence. There's file type, which I've used extensively, especially when looking for sensitive information related to target organizations. And this is where you can do something like file type : XLS if you want to look for old Excel spreadsheets, or DOCX for new Word documents, or PDF, which is a very popular form of document. I actually was doing searches for my day job, and this goes back several years at this point, but doing searches for sensitive information related to our company that might be out on the internet. And we had found where one of our potential clients that we had provided a bid package to. So a huge PDF file that has, all the information, including, diagrams and all this work. I mean, probably tens of thousands of dollars, if not hundreds of thousands of dollars of work sitting in this PDF document, along with, we're going to build this project for, say, $500 million. If one of our competitors was to find that, maybe they can come in and use that to underbid the project. What had happened was the client had posted it, they had put it in a folder on a server, not really realizing that server was exposed to the internet and was hosting their main website. And then that was, of course, indexed by Google, which also indexed the subfolder, which indexed and made that PDF document available. Thankfully, we had found it it was like a day or so, and they were able to get it down, take it down right away. So that was, I think, to me, a great example of finding not just vulnerabilities that attackers can exploit from a code perspective, right, to break into a system, but here, right, we found a vulnerability still. We found a security issue where we had sensitive information exposed to the internet that shouldn't be, and we were able to get it addressed, hopefully before an attacker was able to take advantage of it. And then you can see there's also, we can say in title and in URL. So we want to look for specific terms in the URL, right? The web address where you type in www.netflix.com, or in the title, which is the title of the page you see in the upper part of the browser when you load a new web page. So you can trigger off of each of those. So think in HMI, maybe we'll have a particular title that it places in the browser with specific words. So if you're looking for that one particular type of HMI, you can run a search for in title using those words. And we'll see some examples of those again as we go throughout. And hopefully as you get through this, then you'll be able to come back and create your own queries to find these types of devices. Now, interestingly enough, so the folks that built Kali Linux, offensive security team, they have actually hosted ExploitDB, or if you want, exploit-db.com. So the exploit database is a huge collection of, and this is going back to software exploits. So if I'm using Kali Linux and maybe I use Metasploit to be able to break into a system, right, to take advantage of a code vulnerability. And maybe they're running an older version of a service on a system, and I want to use download a Python script to exploit that vulnerability. ExploitDB, chances are they have that script or that exploit that I can download and maybe modify it for my own use to then take control over that system. That's ExploitDB. Let's jump over there. So this is ExploitDB, or the exploit database. Now, again, these are mostly exploits for, if you want to say, IT systems, right? Windows, Linux, web applications. I'm not saying we don't have these in the OT environment as well, right? If we have these types of systems or applications in the OT environment, this would still be the place we want to go for those exploits. But what we're talking about in this section of the course is if you scroll down to the bottom, you can see under databases. Not only is there exploits, but there's Google hacking, and there's other areas of the page to explore. Here, the Google hacking database is listed, so we're going to click on there. And so what you see, and it's interesting, there's a couple things here we'll look at. One is, here's these different Google searches, or remember these customized Dorks, the customized Google searches that we have. And we can copy and paste any of these into Google and get the results. And we'll look at some examples. You can see they also have them classified in different categories. So things like files containing juicy info or files containing usernames. Remember, we talked about how to find usernames in the last sections. Talking about files containing passwords, something else that we had talked about. So here's other methods that we can use potentially to find usernames and passwords or sensitive information, like the example I shared earlier, just by using Google. And you can see who went ahead and submitted these. And when, you can see they don't actually update this very often. I've actually submitted a few based off of what we're going to talk about today. You'll see some examples of the things that I actually submitted, which I thought were important, but you can see again, they don't really update this very, very often. But the interesting thing that I find is actually one of the examples that we see right here is an OT specific search, and that we can go ahead and use that. I would say before we do that, we just want to actually see, well, what does one of these more general types of searches look like? And so we might look at something like, let's just take one that probably is a little less dangerous. And we can go, and then let's flip over. So we're going to go to Google. We're going to paste in the search. And then you can see any place where it has a quote unquote web page that says that it has that string header for logs at time, and then it has a file extension of .log. It's going to actually display it here. So basically any place you see log files and then that header for logs at time. So we can actually go into one of these if we wanted, and you would actually see this log file. This looks like a WordPress site, right? And you can actually see, right, the log file. And you can see how potentially they could say this could contain usernames. If you actually saw and it recorded who was actually logging in to the system. So that's one idea of how you can find things on the internet. And I think that's probably one of the least worrisome ones that are there. I think some of these, especially the ones that are looking for credentials, passwords, SSH keys, right? Those are ones that present significant risk. So you can explore those on your own, but not something that we're going to be covering in the course. Right? So here, let's go ahead and take the Siemens one though, since it is OT specific. And I'm going to go ahead and throw that. Going to throw that into Google. And so you can see if we're looking at the search, it's going to say anywhere in the text of the page do I see Siemens, and then in the URL, the bar right here, do we see /portal dot MWSL. And the really cool thing is too is, well, if you want, we can Google for this, because we can run this search and then we'll get all these results, which is awesome. And we're going to come back and look at this. But if I'm looking at this first, so we run the search, and then anywhere we see Siemens at the page, in the text of the page, and we have that /portal.mwsl in the URL, the address bar of the browser, then show us those results. And you can start going through these, but we're just going to pick the first one. And I'm going to open up that page. Again, it's exposed to the internet. I found the page exposed to the internet. There's nothing wrong with just opening that page by itself. We're going to go ahead and tell the browser to ignore any privacy considerations. So there's probably expired certificate or weak encryption algorithms, or maybe it's still using SSL version 2 or 3 that the browser is concerned with. But here we can then find, well, here's the web interface for a Siemens device. Right? And then that's what we're looking at so far is what we know. And you can start, if you were to go into the interface and start clicking on options and exploring, then you could get a better idea of, well, what type of Siemens device is this? Now, we do see over here it says PLC local time. So not only do we know, okay, it's a PLC, so it's a Siemens PLC, but also if the time is set correctly, we can get a vague idea of where it sits in the world. So it's potentially Europe, potentially Africa. And then we can also see, oh, there's this ET200SP station_1 neg micon 52. Like that might actually mean something. And so we could do Google searches. So as soon as I put in ET200SP, I don't even have to talk Siemens. I didn't have to put PLC. But what we do get is a bunch of pictures for Siemens PLCs. And then we can scroll down and we can see, oh, there is the semantic ET200SP line. Let's accept our cookies for Siemens. So this is what we're looking at in the real world. And so we can see that there's at least this Siemens PLC running a web interface that's exposed to the internet. Google hit the web page, and as Google does, it indexed that information, put it in its database, and makes it available for search. And that's how we found it. So we have one of these PLCs, maybe not this exact makeup, right? But we have a Siemens semantic ET200SP setup exposed to the internet. And it didn't take anything but going to the Google hacking database, copying at Google Dork, remember that specialized Google search, putting it in Google, and getting these results. And you can see, now that we've gone through that first one, you can look at a lot of these other options and you can start to see, oh, the pattern of, oh yeah, there's the local time listed, right? PLC local. Right? You can see, oh, there's a S7 1200 station. So there's actually, oh, there's a S7 1500, right? So there's different types of Siemens PLCs. But if you enable the web interface on them, they all kind of seem to have this same look and feel to them. And if we scroll down to the bottom, we can see how many of these did Google find on the internet. Now, thankfully, you can see it found 8-ish. Now, it says that it found some other entries and it was similar, so we took those out. So it's like, repeat the search and say, okay, put in all the quote-unquote duplicates. In this case, again, you can see it doesn't actually find that many. So let's say there are 8 of these exposed to the internet. So that's not a lot, but it still is some, right? It's not none. If you had done these searches 5 years ago, you would have had 10 times the amount, at least, if not a lot more. But that's how we can use general search engines like Google to find assets, control system assets that are exposed to the internet, as long as, remember, it has to have a web interface on it because that's what Google indexes. It's not Shodan. It has to have a web interface. Now you can use Bing and DuckDuckGo. Bing and DuckDuckGo really have actually done a much better job at security, believe it or not, than Google. So most of these searches don't function in Bing or DuckDuckGo, which I found really interesting. So let's go back to the slides and we can see, so we talked about the Google hacking database. I do have some other examples, and we started to hint at some of those searches that could have a lot more, let's say, dangerous or riskier information we wouldn't want exposed to the internet, right? One of the searches in this case was where you can find SSH keys to potentially log into systems that could be exposed to the internet, or at least internal systems. So that's definitely something that would be very concerning, that would be of high interest to either a penetration tester or a real attacker. And then, of course, we talk about our Siemens example where we went and found those different assets, those PLCs, right? The different models that were exposed to the internet. In this case, you can see one of the S7 1200s that are exposed to the internet. So if you just click on that link in Google, it pulls up that main page, and it even gives you the little, I guess, their little diagram or picture of the PLC. And that's pretty much what they look like. And then you can even see, based off of the light indicators, that it's in run mode. You can see other sensitive pieces of information they've given it a project name. So basically that's going to be the code file running, the logic running on the PLC. Ideally, you can see the version of the TIA portal, which is what engineers and technicians use to program the PLC. Of course, they've named it S7-1200-station_1. So yeah, we already know it's a S7-1200. That's not giving us a lot of other information, but maybe the name in the project name, the Hasterung, could be a clue. Right, PLC 1. Right, we can see the specific model type. And then, yeah, as we saw by the light, it's in run mode. So it's more secure if you want. So more than likely, you're not able to do things like upgrade or downgrade the firmware of this device while it's run mode. You could still make changes to the logic. You just can't make changes to the firmware. So that's a great example of, again, how we can find ICS OT assets through Google. Now, we can create our own Google searches, right? Anytime we find an asset that has a web interface, we can write our own Google search. Like I said, I've actually submitted quite a few of these to ExploitDB. I'm not offended that they don't publish them. Apparently, they don't publish much. But in this case, you can see this is when the ELITEWOLF project came out, and it was announced by the NSA. And I talk about this in a couple of other different presentations. But when the NSA project came out for ELITEWOLF, I was really excited because they don't release things that often to the general public. So I always want to dig in there and tear it apart and see what's there. And I opened it up, and there were just a couple of text files. I was like, well, that's really not helpful. and I looked and like, oh, well, these are snort signatures, right, for intrusion detection. And so I started looking at the signatures, and they're really simple, really basic signatures, so nothing special. And when I was looking at them, this really had caught my eye because it was, well, this is just if somebody visits the web page on your PLC, which if this is just internal traffic, that might just happen normally with a technician hitting the PLC. So would this create potential, false alarms in the environment, false positives that you would have to respond to and waste your time? It could, right? In some environments, if you're very strict about connectivity, it could be beneficial. It just depends on your environment. So the one thing I also noticed here was, well, that's a URL. So if it's a URL, then, well, just like we were talking, we can put it in our friend Google and come up and look at, run a search. And then in this case, right, we get a list of all the PLCs, in this case, these Rockwell PLCs that are exposed to the internet because they have a web interface that's exposed to the internet, and Google found them. So here's a PLC, here's a PLC, here's a PLC. If you run this search right now, we're not getting to do it in the video. You can run it on your own. But there's about 50 of these exposed right now. So more than the Siemens devices that we were just looking at. And again, a very small number compared to what it would have been 5, 10 plus years ago. So a lot of people, a lot of environments are getting smarter and understanding we don't expose ICS or OT assets to the internet because bad things can happen. But there are a few, right, that still can become exposed. And again, the whole point of this class is making sure, especially, are the assets for our organization exposed, or for our client's organization, are they exposed? We want to find them before the attackers do. But any of these, right, you can run that search and then you can visit the web interface that's on the PLC. In this case, this is the TCP connections page. And it'll actually show you, all of the connections with that PLC. It's just like running netstat on a Windows or a Linux box. Right? We can see whether the connection is established. We can see the local IP address of the PLC. So we can see, it's 10.25.10.40. So like I always say, right, is an attacker knowing your internal IP address for that PLC going to allow them to take control over the network? No. But just the fact that somebody on the internet is able to see an internal IP address from your network, it just means your security is lacking. So you probably have other issues also that could give an attacker access and administrative control of at least one of your assets. So you need to be looking for those gaps and get them addressed. So we can see the local address, right? We can see the port on the PLC that those remote hosts are connected to. So you can see in this case, they're connected to port 80. So the web interface running on port 80 for HTTP. So it's not encrypted. And then you can see in this case, 44818, that's reserved for Ethernet IP. That's a older ICS OT protocol that also runs on TCP IP, which is how you can see it here. And that you can see, if you look under remote address, you can see, that another host internal to the PLC at 10.25.10.41 is talking with this PLC. Maybe it's another PLC, maybe it's an HMI. But then you also see, 74.92.127.13. Like, well, that's a public IP address. And they're connecting to this PLC over Ethernet IP. Now I can understand all the scanners on the internet looking for HTTP, right, web pages on port 80 or 443. But if someone's connected to a very specific, especially high order port that's reserved for ICS OT protocols running on TCP IP, like 44818, then you start to get suspicious. So is this attacker, or maybe this is actually one of their sites using this for communication? Or if you're looking at this list, I suspect there's a combination of both going on here. But we can see those remote addresses, whether they're internal or whether they're external. The remote to the PLC. And then we can see the ports that they're also coming from. Now, one thing I did do was I did create a little ChatGPT script. I thought this was kind of interesting, at least from a, if you want, security researcher perspective, be able to map these out. So looking at this connections page, I thought it would be really cool to be able to understand a little bit more of where these connections are coming from. It was almost like turning this PLC kind of into a honeypot, kind of, for security research, right? I'm just really curious to see where are all these connections coming from. So I used ChatGPT to create a real quick script, and you can see the prompt here. So it's going to connect to that PLC page that shows the TCP connections. It's going to take out the remote IP addresses. And then it's going to display the GeoIP information for each of those IP addresses and then update it over time. So as new connections come from new locations around the world, those locations will be displayed. So here's what it actually ended up looking like, right? And so it's a scraper.py, right? Run this scraper tool. It goes out, connects to that. It'll actually ask you for the URL. So you put in the URL, connects to the page, takes all those IP addresses, and then you can see it maps those to the location based off of GeoIP data. So you can see, oh, there's a connection from Seoul. There's a connection from Philly. Right? There's a connection from Jersey. There's a connection from Wisconsin. There's the private IP addresses, right? So it doesn't know where those internal IPs are. Simpsonville, South Carolina, that's where I live. So that's me visiting the webpage. And then you can also see, oh, then there's these other connections from Wisconsin. And interestingly enough, there's 3 different IP addresses from Wisconsin. This was where I was mentioning earlier or alluding to. I think those are actually legitimate quote unquote connections for this organization. And they're just doing this communication over the internet in the wide open. But over time, the script will continue looking every 60 seconds to see if there's something new. And over about the course of 10-15 minutes, it doesn't take long. You can see, sure, we had all those connections we already knew about, but then you also see like North Carolina pop up. There's more different locations in Jersey. There's Amsterdam. There's more places in Netherlands. And so China, Germany, more from Amsterdam. Just different, completely different IP addresses. Right, we're getting all of these different connections from all over the world. So I find it really fascinating, right, that we have this PLC that's exposed to the internet. Again, it's kind of like a honeypot, right? That you connect to the internet and you want to see who's attacking it. Again, in this case, we're not getting into necessarily who's attacking, but at the same time, why are you trying to visit this PLC? I also wanted to take it to the next step because I actually realized, oh, it'd be cool to see this on a map. It was like, I bet ChatGPT could do that too. And so went back and just said, hey, put them on a map, basically is all this prompt is saying. And so this is what we end up getting. And so you can see here's the PLC, and it takes those locations that we had seen. In this case, I only fed it like, I don't know, 6-7 locations. And it draws them out on the map, just so we can visualize it. I think it hits home. Right? Here's this PLC. It's kind of in the middle of the United States. I want to say it was probably in Wisconsin. And then it was being connected to from all of these devices all around the world. It's another one of those like, why? I wonder what's really going on. Now, it's not a true honeypot, so we don't know. And it doesn't have, true intrusion detection capabilities, at least not that I'm aware of. So we can't really dig into it. But again, I still find it fascinating to see if you do have a PLC connected to the internet, even just within a half hour, you see, this is probably 10-15 minutes, you see all of these different connections from all over the world from assets that shouldn't be hitting it. So it does make you wonder. So that'll be my next research project. Now, as I mentioned earlier, we talked about you can use Bing for doing these types of searches. It's interesting though. So when we talked about the ELITEWOLF project, right, using those URLs that they included in those snort signatures, and then in Google, right, if we ran a search for one of those URLs, we actually got a list of about 50 of those Allen Bradley Rockwell PLCs that were exposed to the internet. If you run that same search in Bing, this is all you get. You just get, realistically, the entries for the ELITEWOLF snort signature files. I was like, oh, okay. So I think they're smart enough, or depending on how you want to say it, right, to filter out exposing the ICS OT assets, which I think is good from a security perspective. It's not interesting, right? From our perspective of trying to see what's out there and find these assets and being able to understand, right, where these assets are exposed and like we saw in the last example, who's connecting to them. But I can understand if they're making the conscious decision to do that for security. I am not going to ever, be mad at anybody for taking a step, to making the world a more secure place. So that's all that you see him being, right? And if you go DuckDuckGo, it's even less. So they don't even give you links to the snort signatures. They're just like, hey, we're not showing you anything. So if you're going to do this type of research, really, Google's going to be your focus. And I think it still is interesting where you can find these types of assets in control system networks exposed to the internet. And we started to touch on that a little bit. We saw some Shodan screenshots earlier, and that's what we're really going to dig into in the next section of the course. And that's going to be the main section, most definitely. Where this one was pretty quick. So again, yeah, DuckDuckGo, nothing to see at all. Bing, a little, but just for research purposes, as far as reading documentation. If you want to find the ICS OT assets, go to Google. That's kind of the TLDR on that one. So anyways, I appreciate you watching the video, checking out the course, and then I will see you in the next part.